Okay, this is the last segment on exponential growth, and it does set us up well for exponential decay, which you're going to find is, very, very similar. So another very common use of exponential growth is compound interest. And compound interest, it's very important you get into your head, only occurs with money in the bank. And what it is you put money in the bank and it starts earning interest. And then the interest begins earning interest. Okay, so for example, if it's compounded and you see it says here n times a year, let's pretend like it's compounded 12 times a year. It's compounded monthly. So you put money in the bank. At the end of the first month, they say, hey, you've earned this much interest this month, and they put that in your account. Well, as long as you leave your money in the bank, then the second month, you're now earning interest on what you put in the bank and your interest. And at the end of the second month, they put in, hey, now you've earned a little bit more interest, and they put that in. And so now the third month, you're earning interest on the money you put in the bank and the interest from the first 2 months. So that's compounding of interest. Okay, so the formula for this is related to our good old y equals a b to the x. It really is. It's just going to look a little different. So instead of y, we see a. And this a stands for the ending amount. So at the end of the time, that's how much money you have. Okay, then we put in what a equals, the ending amount is p, and it's a capital P. And that capital P stands for principal, not like Dr. Plowman. This is P-R-I-N-C-I, and it's still P-A-L, just spelled the same, but it stands for the starting amount, just like A was. So how much money did you put in? That's what it stands for. That's what principal is. Okay, and then we put our parentheses, and in there's going to be 1. So, okay, there it is. You get to keep all your money plus some more. So the deal is when they give you the interest rate, R, that's an annual rate, but you're going to be getting this before a year is up. So we have to divide it by n. And n, as it's stated up here, is the number of times per year the account is being compounded. So we'll talk about that a little bit more in a second. And then our exponent is not just t for time, but it's n times t, because that's how many times it's occurring within the year or being compounded, raised to a power. So let's talk about that n. If the problem says that the interest is compounding monthly, then your n number would be 12, because there are 12 months in a year. If it said it was being compounded quarterly, well, quarterly means every 4 times a year. They've divided the year into 4 sections of 3 months each. And so that would be n would equal 3. If it says it's compounding daily, well, a normal year has 365 days, so we just use 365. We don't worry about leap year. Okay, and I'm trying to think if there's any other that are normal. Those are the ones we usually use. We could have weekly, and then there'd be 52, but these are the ones that we normally see in our problems. All right, so with that in mind, we're going to remember that formula. A equals P times 1 plus R over N to the NT power. I'm actually going to write it down here for us. A equals P times 1 plus R over N to the NT power. And we're going to use that formula for this problem. So it says we deposit $2,900 in an account. Notice it's money in the bank, as I said. It pays 3.5% annual interest. So find the balance after 1 year if the interest is compounded monthly, and we're also supposed to find what if it's just compounded annually. If it's compounded annually, then n is 1 because it's just one time per year. So we're seeing how this compounding helps us. So we're going to set up our first equation. A equals 2,900, our starting amount, times 1 plus, so R is our interest rate, and 3.5%, remember we moved the decimal 2 places to make it into a decimal number, so it's going to be 0.035. So get used to writing percentages as decimals. You can, in your calculator, you can divide by 100, percent divided by 100, and you're going to get that. So we have 0.035 over n, which is the number of times being compounded, and this time we're using monthly, so there are 12 months in a year, so monthly is 12. And then we need to the n, or the n times t. Oh, I'm sorry, I shouldn't have written n and t, right? We need to put the numbers in. That was silly. Okay, so n here is 12 again. So this n down here will always match this n up here, times t, and this is in 1 year, so t is just 1. So when we simplify, we put together our 1 plus 0.035 over 12. So I'm going to take my calculator, which I apologize, you can't see all of it, but it's 1 plus 0.035 divided by 12. Oh, silly me. I wish I could back this up. I can't back it up. Okay, I'm sorry. So I need in my calculator, I forgot to tell you this. When I put it in the calculator, and you can't see what I'm doing, so in the calculator we want to put this part inside another set of parentheses. So I apologize for that. So we have 1 plus parentheses 0.035 divided by 12. And so we get 1.0029. So when I simplify, I get 1.0029 to the, and 12 times 1 is 12, so to the 12th power. Now we're going to put that in the calculator. I'm going to see if the calculator will let me move it. There we go, that's better. Okay, so then we'll have 1 parentheses 1.0029, close the parentheses, to the 12th power. And so we're going to have, oh, that was crazy. I did a silly thing. I forgot to put 2,900. Okay, I apologize once again. I cannot back this up. So 1.0029, here we go, to the 12th power. This is better. Maybe you're keeping up with me since I'm doing this so slowly. So we'd have $3,002.54. So we've made a little bit more than $100, and that's being compounded monthly. Now, if we compound it annually, then our formula is going to change slightly. I'm going to write this in, and I'm going to pause and write this in, so you could pause and see if you can write it in as well. So I've filled in my formula. 0.035 is still our interest rate, but n is only 1 because it's only being compounded annually. And so my exponent, remember n is 1, and times the number of years, and it's only 1 year, so 1 times 1 is 1 when I simplify. And then on the calculator you can see I put that in, and I get an answer of $301.50. So at first we think, oh, this compounding interest thing is really going to make me a lot of money. And sadly, it does not. And this is money, so we want to add the 0 for the pennies place. So the balance at the end of 1 year is $3,001.50, and the difference is only $1.04, and this was $3,002.54. Okay, so we're not going to get rich off compounding interest, sadly. Okay, and that, so let's see. Now we have a checkpoint exercise down here, and so I'm going to, again, pardon the lines getting drawn. I'm going to, again, pause. I'll fill these in. See if you can do these on your own, so you should pause the video. See if you can do these on your own, then turn it back on and check your work. Okay, so here's our two checkpoint problems. For the buffalo problem, everything stayed the same except we put in 11 for the number of years. Just put that in your calculator and you get about 80 when you round it off. For the compound interest problem, there's a few things I wanted to point out. Remember that 3.72, we change it to a decimal. You can put that in your calculator and divide by 100. Per cent means per 100, so divided by 100 to give us that 0.0372, which then is our R, our interest rate. It goes in the numerator inside the parentheses. It said to find the balance after 3 years, so our T now is going to be 3. And it said that the interest is compounded quarterly, so our N is going to be 4. So I filled all the numbers into our formula, and then here's the calculator showing how I put it in. And you will notice I did not simplify first what's inside the parentheses. You can leave that in as it is. You don't have to get a new decimal. You can just put it straight into your calculator, and our answer is $5,587. And round carefully, because the calculator says 0.445, so the 5 rounds that second 4 up to a 5, so we get 45 cents, not 44 cents, which if it's my money, I'll take 45 cents instead of 44 cents. I know it's only a penny, but I want my penny. So make sure that you round carefully. That's the end of this video.